Assalamualaikum. We are from Session 1, Group 1. We'll be presenting about our group project, which is building setting out. Next, I would like to introduce to you my group members. My group consists of 5 members. My name is Julia Elisha. We have Muhammad Shafiq, Ikamal Hisham, Nur Elisa Anis, and Kastina Nakia. Before I start with the objective of our group project, let me tell you a bit about setting out. So one of the crucial aspects of any construction project is the accurate setting out of buildings. The concept of building setting out involves the precise positioning and alignment of structures, ensuring that they are constructed according to the proposed design plans. This process serves as the initial step towards achieving a successful construction project. Let's get started with our group project. The purpose of this setting out survey is to lay out a proposed construction in the survey area using the tachymetry drawing. And throughout this group project, students should be able to prepare design in detail site plans for a proposed engineering project, use the techniques, skills, and modern engineering tools in engineering survey applications, expose students to the concepts and applications of setting out survey, experience in teamwork, and critical analysis in relation to engineering survey in civil engineering. For the theory, I'm going to cover the objective and function of setting out, methods in setting out, and the importance of setting out. So, setting out survey is a vital method utilized to precisely determine the location of a proposed structure within the confines of a plot of land. This involves creating a plan or drawing showing the projected building along with numeric values of setting out elements. Pegs and profiles are then set up to mark the positions of corners, walls, and foundations with separate measurement for individual features such as walls, windows, and doors. Setting out in geometric engineering is to accurately transfer and position the design or plan of a project onto the ground. This involves determining the exact location, dimensions, and alignment of various features and objects within the project site. Essentially, the method of setting out is the reverse surveying process, involving establishing the positions and levels of building lines and road alignments shown on the construction plans on the ground using various techniques and instruments. Several methods are employed in setting out in geometric engineering, depending on the complexity and requirements of the project. These can include traditional techniques such as using tape measures, theodolites, and levels, as well as more advanced methods such as GPS or Global Positioning System, total stations, and laser scanning.
For practice equipments, we need about 7 items which consist of 1 total station, 2 mini prism, 1 measuring tape, 2 pole, 1 tripod, 5 pegs and 5 nails. The setting out survey is a continuation of a tachymeter surveying where the proposed new structure is drawn in the survey drawing. The procedure included establishing on the ground the positions and elevations of building lines and road alignments specified on construction plans using various techniques and tools. The first thing a site engineer must do is read and study the architect's plan as well as the building structure plan, which includes piling layout, footing layout, and ground beam layout. First, must ensure that the plan from the architect and engineer of the structure is consistent in terms of the size of each corner of the building from wall to wall. The second thing must do is check the pre-com plan to ensure that the position and area of the building in the land lot are accurate according to the structure plan and the architect. For the procedures for setting up work on the ground is first, total station at the selected control station is set up. For a datum required to the BS station was also set up. Firstly, we use tape to measure the distance to the first peg of the building by driving a peg at the point with a nail on top. The tape was held by one person at the instrument point and by another person over the B1 peg. The distance and the bearing was checked of B1's peg with the mini prism. The peg was adjusted until the distance is accurate with tolerance of plus minus 0.005 meter. The peg was then adjusted until it was aligned with the calculated bearing. After that was complete, we stretched the tape out and wide to get the position of the second peg. The above procedures were repeated at B2 and all corners of the building. And lastly is checking. All the building lines were measured and recorded the actual distances of the pegs. The diagonals were measured to check the correctness and accuracy of the setting out work.
Okay, for the booking, we look at the table. Here, for the first column, we put the line of the building. And then for the second column is about the length of the building line that have been measured. Okay, the length for the line B1 until B2 is 6.038 meter, and then B1 until B3 is 6.195 meter, and B1 to B4 is 3.600 meter, and B1 to B5 is 5.004 meter, and for the last part is B1 to B6 is 4.002 meter. Okay, next we go to result and calculation. Here in the table, for the first column is the line of the building, and the second column is measure line, and the third column is expected line, and the fourth column is tolerance. Okay, here I show you how to calculate tolerance. First, we calculate the measure line minus by expected line, and then we divide it with expected line. So I use the B1 to B2 value, where 6.038 meter minus by 6.00 meter, and then we divide it with the expected length with 6.00 meter, and the answer for tolerance is 0.00633%.
Assalamualaikum, I am Nur Elisa Anis binti Azli, AN 210067. We'll be explaining about the AutoCAD drawing. So this is our AutoCAD drawing. Okay, so this is our building that has been drawn using the result obtained from the setting out process, and the detail of it will be explained in the next slide. Okay, now I will explain the detail of every colored line. I will start with the straight blue line. The straight blue line is indicate the building line. Next is small green, and there is two lines here which indicate the roadway, big or large green, and lastly our building. In our plan, there are several factors or things that were included, which were trees, manhole, fire hydrant, dustbin, and walkways. These factors are very important to be sketched in plan according to their bearing, to make sure the building can be placed at empty spaces, just like this. For our plan, we chose to build our building near the Station 5 as it is suitable to locate it, as there is an empty space here. And this drawing is drawn in 1:300 ratio. Okay, from the result obtained, which has been presented by Hisham, we managed to get our building, but there are some errors which make this line is not perpendicular to this line, and the error will be presented in discussion from Shafiq.
The setting out survey is vital for accurately positioning and marking the proposed construction. Error in layout drawing can occur, leading to discrepancies between the planned and actual building placement. In our case, a bearing error results in a tolerance of 6.33 times 10 power negative 0.0%. To minimize error detection, we need to ensure correct bearings in the drawing and conduct a two-peg test for leveling equipment. Truly, reviewing and understanding architectural and engineering plans is crucial. By taking this measure, we enhance the accuracy of setting out survey and ensure the construction aligns with the intended design.
To conclude, setting out ensures the accurate implementation of designs, thus minimizing errors and ensuring the quality and safety of construction projects. It helps in avoiding costly rework, ensures proper alignment of structures, facilitates efficient project management, and enables effective communication between different stakeholders involved in the construction process. Accurate setting out also contributes to the overall efficiency and productivity of the project, as it provides a reliable foundation for subsequent construction activities.